right. Good morning, everybody. Usually, I don't get up so early for the Coast Cup for the previous several years. This is one of the first time that I come back and deliver the first talk of the day. So, a quick introduction to myself. Not everybody knows me because Coast Cup is a huge user community in Taiwan. We have so many different communities from different area of the software ecosystem and also in the different regions. So a quick introduction for myself. I started working on the open source project like 25 years ago when I started from Kaohsiung. And later I actually, I was one of the few members try to start the Coast Cup conference. And since then I was be able to actively participate on several user groups and communities, like including TOSAC. I'm pretty lucky. During one of the Coast Cup, I think one of the managers from Kernel, he joined the TOSAC, and I met that manager, and eventually he think I'm a good fit for the company, and he hired me. So since then, I've been working in Kernel for over 15 years. Right now, I'm the engineering director in Kernel, and my focus is always on the hardware and firmware and software integrations with the leading silicon partner and OEM partners. So today I'm going to share a little bit about my view on the reason hardware development and AI world. So I spent some time reviewing all the sessions for this year. So this year in Coast Cup, we have over 356 sessions for the 2 days. I have a deep look of it. I realized actually one of the 4 sessions are related to AI topic and really focus on AI topic. And even they are not focused on AI topic, almost over 37% of the topic mentioned about agents, ALM, AI topic. And there are a lot of interesting topics in these 2 days. I'm really interested to listen to these speakers to see how they think about AI and how they are using AI in their work. So, like at the beginning, we were mentioning about AI is one of the trading technology compared to 20 years ago, and it changed the way people working on software and open source at all. So today I'm going to share a little bit about what are the new technology we are seeing from the hardware side and how much impact the software on open source, and what are the potential approach that we can do to support all of these upcoming new technologies and how a developer can do with this. So in general, the open source community seeing AI is more like a tool. Of course, in these 2 days, there are a lot of sessions talking about how do we see its impact with the open source community, what is the legal perspective, what is the implementation use cases for different AI models. But in general, I think for our open source community is widely adopted already. Like for example, like Nana say, he say the AI is a tool, it's not magic, and we should always see it is just a tool to support the community building a better software, better and secure software. And of course, this also introduced another new challenge for everybody, because with this AI technology, we can see there are so many, it's so much easier to identify, for example, the security vulnerability from different software, right? You can see in the last few months, there are so many security vulnerabilities being identified. And you can see your platform has been updated, need to be updated for the new kernel or new software almost every week, every day. So, when I want to talk about it is, if we take a step back and look at the hardware technologies from 10 years ago or 20 years ago to now, the world is actually changing quite a lot. At the beginning, when the CPU is still the king, at that time, I think there's a law called Moore's law. it means every 18 months that you will get a performance bump. You don't need to do anything on the software side because hardware will always growing in 18 months. However, it still have challenges. Later, people start to realize there is actually a physical war for single CPU processing because eventually you will hit the thermal issues. Eventually, you need to try to do a more code to handle multiple tasks in parallel. So that is a new generation of the hardware side that different CPU vendors start to introduce more codes on the processor. And then recently they realized in order to do more of the computing, there are some bottleneck on the ISA design, and also it become realized actually because in order to do more computing in parallel faster, a faster instruction is actually bring more advantage in computing and the resources wise. So at that time, you can see people start to introduce the GPU, and then I'm going to talk very quickly because we don't have a lot of time. And then in the recent years, not just the CPU like CUDA, but we also realize there's another challenge because once you introduce GPU, there's another challenge become how do you copy the data you want to process in between different components from CPU to GPU. It become more and more realize the bottleneck about the memory copy is become a challenge for the hardware design and the software side. And later, in order to optimize the different use cases for data center and for edge, we can see a different company are introducing some sort of the ASIC design for the NPU processing. So eventually we are seeing is in the single hardware, from the single CPU architecture, it become leveraging some GPU, one GPU, and then two GPU, and then now we have the NPU and even some sort of the coprocessor on the motherboard. So I call it is a hardware rule. A hardware rule. Why is it? Because in these words, you as the OS or the user, you need to handle many different technology in the same setup. The work has become more challenging. However, the focus of my team has been working on is as Ubuntu. People love to use Ubuntu because they realize they can spend more time building their own application without worry about what are the right kernel versions, what are the driver they should put on the Ubuntu device, right? On the kernel space. So that's how people using Ubuntu. However, in the modern world, we can see there are more challenges because now you are not just need to worry about the driver itself. You need to worry about how you can handle your memory copy, how you can handle your data transfer between systems. And from time to time, you will hit some issues. Like for example, there are dependency from kernel space to user space. There are dependency on the memory architecture. In order to adjust the memory copy issue, some of the hardware silicon vendor, they are introducing some sort of new architecture called unified memories. Meaning, in order to share the memories, they try to using the single memory space, so you can easily to move data or even do a zero copy of the data. So in the hardware architecture side, we can see people are introducing different interfaces to connect different components. One of the previous, if you are using a desktop and using a NVIDIA GPU, the most use case you are using is probably PCIe interfaces, right? In the PCIe interfaces, basically everything is handled in the DMA memory, and you need to copy the memory by yourself, and the hardware handling is over the DMA IOMU. On the other architecture like AMD, they were using CSL, which is be able to enable you to share the GPU memory between the CPU and GPU and GPUs. On the NVIDIA side, they are introducing another technology called chip-to-chip. So all of these, on this table you can see, sorry, the wording is a bit small. You can see for the different unified memory architecture, you have to handle the things a bit different. For example, it could be yourself as OS to handle a memory copy. It could be the hardware itself to handle memory copies. So for the kernel space, it's actually much more complicated. In the recent kernel development, after the Linux kernel 6.1, the Linux kernel actually introduced a tier-in of memory access in order to handle some of the, for example, the caching problem for the AI workloads. So these are the challenges we are facing. As a developer, I think most of the users will want to be able to build their own AI model, or say they want to be able to use open cloud or using an AI agent on their system without worrying about what exactly the hardware architecture is. And this is what we want to address here. What I call it is an invisible architecture, meaning that we want to make this kind of the pain points invisible for the users. Hopefully, eventually, it will be like the last 2 decades. When people choosing to run their workload on Ubuntu, you should be able to just install Ubuntu and then deploy your application and it will just work. Ideally, there would be the situations. It was not as good as is in the last 2 to 5 years. Because, for example, I think people are using like NVIDIA CUDA in the previous time because the NVIDIA kernel driver was not purely open sourced, and there are some dependencies from the NVIDIA driver and the kernel driver. And not just because that, there are also some challenges about the NVIDIA kernel space to user space. Sometimes you can see your AI workload suddenly stop to working after you do upgrade because the dependencies suddenly are broken. 10 to 20 years ago, I think there was a famous picture from Linus. He's pointing one of his fingers to NVIDIA, say, oh, it's quite challenges. I was one of the members doing that outside of the stage. But after I joined Kernel, I actually have the opportunity to be able to working with these security partners, including NVIDIA, to try to address the problem better. So following, I will try to explain what I'm trying to do here and how we can improve the situations. So quickly recap about the 10 slides that I quickly walk through. What we are seeing is from the 20 years ago, the general purpose era has already passed. Right now, we are seeing a much more diverse hardware design and architecture. And from OS side, we have to design a better architecture to support it. We are seeing, because the technology is so fragmented, different companies have a different way to handle the unified memory, have a different way to handle the software architecture. So when I engage with the NVIDIA, with AMD, with MediaTek, everybody have a slightly different view about how things should be getting done. So this is one of the interesting area in open source world, because ideally we want to be able to support all the architecture with the open source. But I think in the real world, due to the different IP issues between different parties, sometimes there will be conflict. And I won't always complain about is the problem of the silicon vendors about they don't want to open source. I think it's just the way the open source work. We want to be able to open source everything and put everything in one place. Like, for example, one of the challenges I was mentioned about the challenge for NVIDIA driver in the previous couple of years. One of the challenge because of that is because the Linux kernel never want to commit on the API capabilities. Because in the open source world, everything should be open source and everything should be put together. So, but in the recent years, I think NVIDIA start to changing the strategy from their side. One of the challenges they were facing was there was some scheduling issue problem they want to address in the proprietary kernel drivers. But in the recent NVIDIA drivers, they introduce these open kernel modules. So their kernel module is actually run as it's open sourced. So the compatibility is much less, but still there are some dependency issue on the user base like CUDA. So I call this is the AI tax. I mean, doing the integration, in order to get your workload properly working, you need to pay the tax. What does it mean? It means you need to know how to get the right version installed on your system. How do you manage your dependency? How do you configure everything? Sometimes it will be painful. Sometimes it will be painful. And how can we make it easier for everybody? So from the chemical side, from my side, actually we has been working with like NVIDIA AMD. So start from this release 2004, we are actually be able to ship, like for example, the NVIDIA CUDA library with Ubuntu. So previously, for example, the CUDA library has been shipped independently on the NVIDIA archive. And because now we are able to put them and ship them together, we are able to run the regression testing at our software updates. So meaning it will have a less chance for you to receive an incompatible update from different companies. And we are also integrating something like AMD Rock'n stack in Ubuntu. So, and also Qualcomm, MediaTek, we are doing the similar things. So ideally, eventually, you should get all the necessary user space SDK from the single source from Ubuntu, and which will be qualified and validated by Kernel. And this should be able to reduce the risk for you to run your AI workload. But still, like I say, it's still quite complicated because different vendors have a different view about how things can be done. Sometimes they would need to work around the problem by shipping a proprietary bit because not every silicon vendor have the IP of the technology. Sometimes they purchase the IP from the other companies and it become a critical problems for the open source world because ideally, because in the open source world, every developer is supposed to own the IP of your code. You know what exactly you are writing. But in the commercial setup, actually, they are using the different source code or different driver from different vendor. There are some constraints. And after all, the open source community is always trying to build a design, a software architecture that can be compatible and support very diverse hardware ecosystems. Still challenging, but we are introducing several approaches to address this. One of the, in the following session, I'm going to talk about two solutions, two ideas that we have been working on. Both of them are open sourced, and to address the problem I just mentioned. The first one I'm going to introduce is the inference step. So what does it do? In some of the OS, including Microsoft or Mac, I think I saw a Mac ad yesterday. Somebody was in a conference and the host asked that individual asked him to present something on the data. And he just moved away from his meeting room, then using the AI function on his machine to do inference and generate a key outlier and takeaway for the presentation. The processing was done locally on his machine, on the Mac. This is added from the Apple Silicon. However, when we are using the open source software, sometimes we are using the hardware from framework, we are using hardware from Dell, we are using hardware architecture from like AMD, Intel, or even NVIDIA. All of them have different technologies. How can we support them in a single setup? I think that is one of the challenges we are facing. So in order to do this, one tool that we introduce is the inference step. What does it do? There's a command there. If you are using Ubuntu, you can try it. You can do step install Gemma 4. What it do in the background is it will try to, in order to set up a local AI model on your machine, you need to think about several things, including, like, for example, what are the right runtime you want to use? What are the proper model weights can be supported you with the memory you are having? Because if you don't have enough memory, you probably won't able to run a large weight model, right? So you need to think about all of these details, and it will be quite painful for you to set up one by one or even compile it by yourself. So this utility with Snap is actually help you choosing the optimized AI model on your machine and choosing the right runtime for your machine and choosing the right size of the model for your machine. And you also provide the pre-trained model, so you can just do the Snap install and you will download the pre-trained model from the internet. So basically what it does is when you install the inference Snap, it will detect what are the silicon you have been running. Are you running the AMD? Do you need ROCm? Are you running NVIDIA GPU? Do you have a CUDA installed? It will manage this dependency for you. And secondly, you will try to find what is the most faster processor on your platform. For example, on the recent Intel or AMD platforms, you will have a very powerful CPU. It usually comes with the NPU with you. It can do some sort of the AI workload, but sometimes the user may think about it's not enough, so I want to install another GPU, a powerful NVIDIA GPU. So the application here, they will try to identify what are the core processors available on your machine, how much of a memory available on your machine, what is the memory architecture on your machine, and choosing the right format for you. If it's not working, for example, if your platform, you have a limit budget, you don't buy a very powerful hardware, still, you can still do the AI workload using the CPU fallback, right? So eventually, if you install the software, you will be able to have some sort of the local AI model. Everything will be compute, inference locally on your machine. You don't need to worry about the privacy, you don't need to worry about the security. Everything will be handled locally. And also, you handle the software update for you. So this is one of the easy way for a user to try to deploy an AI model on your machine. Eventually, what it exposes is a local OpenAI endpoint on your machine. So meaning after this application is running, you will be able to implement something talking to the OpenAI endpoint on your machine. So at 2604, we haven't introduced anything integrate with AI on the Ubuntu OS on desktop yet. But in the future, once this inference Snap is mature enough, potentially you will see there are some AI function will be made available on the Kernel setup because you will be able to access to the local inference capability based on your hardware. Yeah. So this is a list of the model, but you can try to install on your machine. You can try today. So this is one of the challenge we will try to address here. We want to give a user a just working out-of-box experience. You get your Ubuntu installed, the local ORM should be just working. You'll be running locally on your machine. You don't need to worry about somebody will see the data you are transport. You own your data. And you can predict how much money or cost you want to spend on your software because you only need to worry about the hardware you are buying, the power consumption you are paying to run the model. So this is one of the story that I'm sharing to address the new hardware rule, the hardware ecosystem, to make it easier for people to start to use AI right away. So this is a story for the Ubuntu desktop or for the edge device. Another interesting project we has been working on, we call it is a workshop. So another challenge we are seeing for the developers, especially, no matter if you are going to train your model or not, eventually you may want to write an AI application to leverage the different hardware capabilities. So as a developer, you cannot just use, you probably won't able to just use the inference net, but sometimes you want to try different model, you want to try different parameter, you want to change the way of the model. In order to do that, you need to set up your own developer environment. there are so many potential approach on the market, and this is one of the idea that we are proposing. Instead of using your bare metal to build the developer environment, it's easier for you to create a different development environment using a configuration files. So the problem we try to address here is we want to give user a reproducible workspace. Why is that? Because in order to say, well, I want to run a CUDA or you want to run a Rocken, there are always newer version of the SDK available on the market, and this new SDK may have dependency on the driver, on the different software development packages. So eventually you need to manage the dependency between different systems, and they are not always available in a single source or in the same format, right? Because it's going so fast. Some of them are Python packages, some of them are Go, and how can we handle this better? So the story we are offering here is we want to provide you environments. Docker could be a container solution, could be a good story, but container won't able to give you all the flexibility for you to hack up the file system. During the development, you want to hack. You don't want to be constrained in the very limit environments, right? So our thinking is you can run the whole development ecosystem on the ASD, on the virtual machine, or on a container. But it's a developer-friendly environment. There's no constraint. You can do whatever you want. The most challenging thing is how can we help you install the right SDK and software on the environment. So this is one of the typical software that people would want to adjust. Typically, you want to install the system-level drivers, SDKs, and then you want to install some of the middleware from a second vendor, and then you probably want to install some AI model, AI runtime like PyTorch stuff, and then you probably want to have a Juniper notebook for you to do some quick development and do quick experimental. So this is one of the typical software setup. Meaning if you are doing from bare metal, you need to set up it one by one. It could be very, very complicated. And some of the companies, they are giving you some script to set up, but still it's hard to maintain. So in order to make it simple, this is how we propose it. This is the configurations for this project workshop. Is a YAML file. You can configure what type of SDK, supported SDK from Ubuntu from Kernel. So you can select in what are the SDK you want to install on this virtual machine, what are the version you want to use. And with this setup, it can be easily combining and installing all these software into the virtual machine. And you can use one single command, workshop refresh, to update it to the latest version. You can try different combinations. So with this setup, it's much easier for you to try out different versions with different combinations, and you don't need to worry about you break it because you can always easily recreate the environment by one command. So when I call it invisible architecture, this is a joke for my team because even though my team spent quite a lot of time doing a lot of integration and a lot of the architectural design, but most of people using Ubuntu don't realize this. They will feel like it's just working. It's supposed to be just working. So nobody is seeing the work from my team because it's transparent, right? So that's why I call it is invisible architecture. But in reality, we actually spend quite a lot of time doing a lot of very low-level integration work. Like for example, your audio or hotkey will be working. Probably is one of the chemical engineer was troubleshooting it and fixing, asking the OEM or the ODM vendor to fix the implementation in their BIOS or in their hardware. So there are a lot of this kind of work has been done in the background. And not every of them are like changing the open source world. In order to make the user experience better, it's actually a lot of work between the Linux OS, the kernel, the user space, to the hardware, and to the firmware itself. That I try to explain in this session. With the reason hardware changes for the AI workload, we are seeing a much more fragmented architecture. I'm not going to say that we address all the problems. We only address a partial problems. This is a big step forward because we are able to include in the user-based SDK from different vendor, Intel, AMD, NVIDIA, make it easier for user use. Make it easier for us to capture the regressions between kernel and SDK, but still is not enough because there are still a lot of fragmented architecture in the open source world. Okay. So a little bit promoting for my team. So actually we are hiring in Taipei, in Taiwan. So if we are interested about the problem I just shared here, in terms of be able to engage with the world-leading silicon partner, with the key OEM customers, be able to make an impact on how the open source should be look like as architecture to support this new modern world. Feel free to come to me and we can have a chat about how we can support this. Okay, so I think I end up earlier due to we also start earlier. I think right now is a good timing for questions. Any questions for the information I just shared?你也可以用中文。
现场有什么问题要问 Rex 的吗？
你好, I think I know you before, long time ago. My name is Paul from HRF. And my question is, how can you deal with most of chipset company? Because chipset company, they are includes all the proprietary soft code. So do you need to pay them, or how can you deal with? Because my major product now is a MediaTek Wi-Fi product. So actually we got a lot of resources, but we still need to pay some. But I'm wondering how can you deal with them?
Okay, that is a very good and interesting question. So 25 years ago when I sit side by side with you, I always feel the same way. Why these hardware companies don't just open source the SDK and stuff for us? And I later realized that from the commercial perspective, they only invest resource when they see a potential commercial return, right? They always want to see if there's a return for them so they can invest. So one of the daily work for me is always to find a story that we can build a win-win situation for the second partner, for the OEMs. We always need to think about not just what the user needs, but we also need to think about what a second vendor needs, right? Eventually, what they want is they want to sell more of their silicon. They want to sell more of their hardware. And the story would be, how can we make that happen? How can we build a better ecosystem if they are doing a certain things with us? Like when I mentioned about the different hardware architecture, when I mentioned about different IP, I'm facing the same challenge. Right? For example, MediaTek the 5G modem module, the IP of the 5G modem module could come in from different companies. Eventually, you probably will see a module coming from one OEM, but it actually is a combination with different vendors like MediaTek or Intel. Even sometimes they are even like using IP from each other. So eventually, the story I always want to sell to them is, in the open source world, in order to build this better ecosystem, in order to enable the AI to be quickly deliver the solution for them. If the code has been open source, if the code has been upstreamed, it's easier for their downstream customer to use it. But the storage is not always enough. Sometimes I need to tell the OEM, hey, we want to ship this machine for like 10 millions of the units. We want to target the AI world. How can we make this happen to build a better developer ecosystems? In order to do this, we probably need every bit in the OS to be open source. If it does not open source it, what are the consequences? Like for example, I mentioned this time in 2604, we be able to release the CUDA or Rock'n together with Ubuntu. They were not seeing the value of it because they were thinking about maybe the developer just install it, it will just work. But the real reality is the developer was suffering because there are version dependency, there are compatibility issues, they are not doing enough testing on all the different machines, right? So the value we tell them is, hey, if we are able to open source it, OEM is able to commit, say, I'm going to ship a certain number of a machine. This would be the return of the investment for the silicons. In order to do that, then we can build a program together and try to launch it. So you're asking interesting questions on the commercial setup. How do we make them work? Paying them is actually not a great solution because the revenue does not always come into Kernel. We are able to sponsor, we have a revenue to sponsor software development. We can sponsor some open source community or conference, but we probably won't able to go back and sponsor a silicon partner. So actually, the way it operates today in the commercial setup is the silicon partner is actually paying us to build an ecosystem with them, right? But they don't see it as just an NRE fee for Kernel. They are seeing it as an investment because they can see the commitment from OEM say this investment will give them a certain number of the shipments, and they will get the money back after that, right? So we call it is a silicon partnership, right? So it's not just a one-way transaction. It's an ecosystem that we want to build a better user and developer community for everybody. I hope I answered your question.
Any question? Okay.
30% of the time in course coverage should be just listening to the session. 70% of the time should be making friends, right? So ask all questions, please.
Oh, thanks for the talk. And I would like to ask whether the inference snap currently supports Rock'n, because last time I tried installing one, it runs on CPU only. Yeah.
Right.
Thank you.
So inference snap is a very, very new initiative from Kernel. So I don't know how long ago you were trying it. It was beta, I think, a few months back, and right now it's much more mature. And I'm actually building a beta risk plan with the team because, like I say, we are seeing a quite fragmented market ecosystem in the world. We want to support Intel One API, we want to support AMD Rock'n, but because there are so many diversity of the setup, the way we do is in Taipei, Xizhi, we actually have a device lab. We collect more than 3,000 different devices from different OEMs, including laptops, including workstations, including IoT devices, single board computer, and try to run regular recurrent testing when we do the kernel release every 2 or 4 weeks. So ideally, all of these infrastructure should be tested and covered in all of this hardware, but to be honest, it's not enough right now. So you can still encounter some challenges, but I think it's just the nature of the development. It will become mature from time to time. Yeah. And feel free to report back. Yeah. So one of the interesting topics I mentioned is at the beginning of this session, I mentioned about because the AI assistance security scanner, we can see security being reported almost every few days or every week. Previously, we were releasing the kernel every 2 or 4 weeks actually. But in order to support these new crazy AI worlds, we are working on trying to reduce the release time to every week for a new kernel because there are so many new security vulnerabilities identified recently. And it's also another challenge because it keeps changing the fundamental kernel space. Any more questions?
So from the session, we know that Ubuntu are integrated with the hardware and the vendors. So like we don't, I think it made like a abstraction layer about the hardware. So we can use the like hardware feature without worry about the what hardware we are actually running on. But like one thing I want to ask is about like, do Ubuntu also plan for the like software orchestrators integrations like Kubernetes or something like that? Because like for the hardware integration part, we are like running on a single PC or a single hardware. But like for a data center, like we may have a cluster with mixed up different kind of hardwares. Did this kind of integration also a plan in Ubuntu?
Yes, very good questions. I intentionally skipped this topic because I think the Open Asia team did a great job. We invite several interesting speakers and topic to the session. So I see 2 sessions about it. There are 2 sessions talking about Juju, right? So one of the sessions is about deploy Kubernetes using Juju. And I think you can try to listen to that session. So Juju is one of the product from Kernel as well. So it's basically an orchestration tool that you can deploy a large scale machine in the data center and to even deploy the machine learning operation stack using Juju. So that's one topic. The other one is Paul Dollar. He's also sharing about leveraging Juju to set up a small set. Like he's setting up an LSD environment and deploy open clouds on it. So I think these 2 topics is quite interesting, and they address the question you asked. Okay.
你们还有问题吗？可以尽量提
还有问题吗？
问，还有一些时间。对，we still have enough time to have any question. Do you guys have any questions?
Yeah. I think I also start 10 minutes earlier.
Yeah.
Yeah. Okay. It's okay. I'll be around, so I think feel free to come to us. I think I will also go to the booth, so we can have a chat in these 2 days. All right? Okay. Thank you.